because it is within each department. Next, second ranks, fourth ranks, fifth rank, sixth rank, means whoever is getting first rank maybe in all the sections or first rank in all the classes 1 to 10 will be displayed in the beginning. That is what it will do when we rearrange, when we arrange based on the rank or based on the dense rank also. See, in this example we are arranging based on the department ID. We are taking rank, dense rank, row number from employees table, partitioning by department ID, order by salary. We are doing order by department number. Now we will see the actual ranking in each department. Now let us take count. Count in each department. We are taking rank, dense rank, row number, count also. Count will be repeated, but it's fine. Order by department ID. When we take the count, we don't use order by here because we need total count in that particular department. Partition by department ID. We need count for each department ID. See, 10. The count is 1. 20, count is 2. 30, count is 6. But 6 is repeated because of rank, dense rank and row number. Otherwise, only once it will be displayed. Let us see the next query. Yes. Here we are using count as an aggregate function. Sorry, an analytical function. We are using it as analytical function. Department ID, comma, count star over partition by department ID as department count from employees order by department ID. For each department it is giving the count. Maybe we can take the distinct so that only once it will come. See, distinct department ID, count star, partition by department ID. It is giving total count in each department, total 12 rows. Now let us use the count as an aggregate function. There we use group by clause. Department ID, count star from employees, group by department ID. See, when we use analytical function, the elapsed time is 0.04. When we use aggregate function, the elapsed time is 0.07. It's almost double. See, in aggregate function, this is aggregate function using group by clause. It is taking 0.07. When we use analytical function, it is taking 0.04. Let us run now and we can see the difference. We are using it as analytical function. The elapsed time is 0.8. Using aggregate function, it is 8. Both are same. There is no difference. Since data is very less, we are not able to see that. It's almost 7, 8, 9 it is coming. When the data is huge, then we can see the difference. Maybe we connect to SH. Now select, what is that, promo ID, comma, count star from sales, group by promo ID. It has taken 11. Okay. Select distinct promo ID, comma, count star, then we use over partition by promo ID from sales order by promo ID. Normally order by is not required, we are just using it here. Order by is not required. Now we can see the difference here. See, when we connect to SH schema, we connected to SH, we executed promo ID, we have used aggregate function in the first place. So the execution time is 0.11. Now we use analytical function. When we use analytical function, the execution time is 0.6. So it is almost half, 11 and 6. Analytical function is taking less amount of time. This I'll say count. So when we use promo count, okay. So now the time is 0.06. Aggregate function, it is taking 0.11. It's exactly half. If you remove order by also, it is taking same amount of time, so we don't require this. So this is the major difference between aggregate function and analytical function. When we use count function as aggregate function, it is taking double the time, and when we use count as an analytical function, it is taking half of the time with the data of around 9 lakhs rows in the table. If the data is still huge, then we can see still drastic difference in the response time of aggregate function and analytical function. Next, lead or lag. Lead is the next value, lag is the previous value. By default, both of them will give the immediate next value and immediate previous value. Let us use them. We are selecting department ID, employee ID, first name, salary, and then lag on salary we are taking. By default, we are taking the first position. By considering the current position as 0, take the value which is present, one position previous, one position next. Current position will be considered as 0. Partition by department ID and salary, order by salary. We are arranging the data in ascending order of salary in each department, and then we are finding lead and lag values. Lag as previous salary, lead as next salary. Let us see department number 10, 20 has 2, let us take 30. It has 6 values. The original salary 2500. It is the first value. The previous salary nothing is there, so 0. The next value is 2600. For 2600 previous is 25, next is 28. For 28 previous is 26, next is 29. So like this. For 11,000 previous value is 3100, next value is 0, because it is considering the one position before and after. The same thing in case of 50 also. So there is no partition by here. We are considering the entire table as one partition, one group. In the entire table we are finding the previous and next, arranging the data in ascending order of salary. Smallest is 2-1, next is 2-2. See, for this 2-2 previous is 2-1, next is 2-2 only. One position. It will not consider based on the value, it will consider based on the position. Arranging based on each department, lead and lag, the same like previous query. Now we are order by department and salary together. But here we are taking 5th position. We forgot this. 5th previous value, 5th next value. Here only 1, 2 only, so all zeros. 30 we have 6 records here, so we can find 5th value. So for this, up to here, from this position, 5th next value 1, 2, 3, 4, 5. And for this 5th previous value 1, 2, 3, 4, 5. So this is the position, and by considering 0, the current position we are considering as 0, and then we are taking 5th. The current position can be considered as 1 or 2 also. Let us see our next examples. I think it is not there. If you consider this as 1, then take the 5th position, then 30 also will become zeros. If you consider this, considering this as first one, take the 5th one. That means this is 1, 2, 3, 4, 5. This will be the 5th position from 1st position. So however we want, we can consider this. First value and last value. First value of salary over partition by department ID, order by salary in ascending order. Let us take 30. We are arranging in ascending order. The first value is always 2500. The last value should give 11,000. But there is a catch here. So when we read this record, first value is same, last value is also same. When we read this record, first value is 2500, last value what we have read till now is 2600. So it will give 2600 only. When we read this, for in this department, the first value is the first value which we consider, that is 2500. Last value is, this is the last value what we have read till now. That is why last value is like the last value till now, not the last value in the entire result. That is the catch here. So when we arrange in descending order, then it will change. See the next query. We are taking the first value in ascending order, salary and first salary of each department. See, in 30, the first salary is 2500. In 50, first salary is 2100 in all these. When we, this is also same. There is no difference. We need descending order. It is also same. What is happening? This is also same, but we are taking the distinct department ID. So instead of repetition, we are taking the distinct. So what is the first salary of each department? The first salary in the sense, if you arrange in ascending order, it will be the least salary of each department. If we arrange the salary in descending order, then it will be the topmost salary in each department. That is possible using first value directly. This is also possible using rank. We need to arrange the data in ascending order. We need to specify where rank equal to 1. That where condition is not required when we have this first value. We can take either least value or highest value in each department. We need to choose the ascending order or descending order of particular column. Now it is giving, since it is ascending order, the smallest value for each department. Now if we use last value, again it is coming as repetitive. It is not giving 1, it is giving the repeated values, last value, distinct of this one. Total 174 records. First value, if you use descending, then we will get the highest values with only one record. Last value, see here we are getting minimum first value in ascending order as minimum salary, first value in descending order as maximum salary. So both the purpose will be solved in case of first value itself. See, this is the minimum salary and this is the maximum salary of each department. Least salary and highest salary of each department we are getting through the function first value itself by arranging the data in ascending order and descending order. How do we achieve this using traditional method? When we use analytical function, it is taking 0.06 seconds. First value. If we use group by min salary, max of salary, each department, group by department ID. I think it is repeated here. Okay, this is order by. Okay. Now this is taking 0.09. Here it is 0.06. It is 0.09. Absolutely, it is more than the time which it is taking in analytical function. So aggregate functions also we can achieve the result, but it is taking more time. Here it is coming duplicated when we use last value. It is not single. So when we use last value, we can use rows between unbounded and preceding and unbounded following. Unbounded preceding, unbounded following. This is something like the immediate previous value, immediate next value, something like that it will be giving. This is where we are using first and last. So we are fetching the data from employees table where department ID in 30 and 50. Order by department ID, employee ID, hire year. Yeah, both are same. We are taking the year part in the hire date, employee ID, department ID, year as hire year, and then salary. We are using trunk of average salary. Keep dense rank first order by took care of year. Dense rank first order by based on the year over partition by department ID. So here we are using the first analytical function. See, hire year 94, 95, 97, 8, something like this, and then the salary average salary it is common. Dense rank first, the first value will be displayed everywhere.